Just like any table in a database, we need to define a primary key to uniquely identify each item inside the table. In case of DynamoDB, we need to define a primary key as well for the tables and for secondary indexes. We'll see how we do that for secondary indexes in later lectures. For now, let's understand how we can define a key. In DynamoDB table, we can define a primary key in two ways. We can just have a simple partition key, or we can have a combination of partition key and a sort key. And you need to define the primary key when you're creating the table. So once the table is created, you cannot change the primary key. So what is partition key? It is nothing but a simple primary key composed of one attribute from the item. Now, no two items can have the same partition key. So for example, you have a table for orders in an e-commerce application, then order ID can be a partition key because it is not same for two items in an orders table. Now, sometimes you need to create a composite primary key, which is nothing but a partition key and a sort key. So in this case, you can have different items with the same partition key. For example, in orders table, you can have orders mapped to different customer IDs. So multiple items can have same customer ID. So in that case, you can have partition key as customer ID. You can also define sort key as order ID. So the combination of both partition key and sort key will always be unique. So this allows you to have more flexible querying in the table. Now always remember that primary key attribute must be a scalar, or it can hold just single value, which can be string, number, or binary. So you cannot have a nested primary key attribute for any of the items. Also, unlike any SQL database, you do not have to define all the attributes for the item in a schema, because DynamoDB tables are schemaless. So the only attributes you need to define, or should I say the partition key or primary key, needs to be defined, and all the other attributes are not needed at the time of creation of the table. Now let's go ahead and see how DynamoDB saves each item in a table using the partition key. Now in the first case, when your table has a simple primary key or just partition key, DynamoDB stores and retrieves each item based on its partition key value. Now before writing an item to a table, DynamoDB uses the value of partition key. In this case, we have order ID here inside the item as partition key. So DynamoDB, before writing this whole item to our table, will pick order ID, and it will send this value as an input to its internal hash function, which will give out the partition ID or the partition in which the item will be stored. If you're trying to read an item from the table, the opposite direction, then again you must give the partition key value for the item that you're trying to fetch, which is the order ID. Again, DynamoDB will use this value as input to the hash function, and the hash function will give out the partition from which the item can be retrieved, or in which the item can be found. Now all this hashing and retrieving and storing of item inside the table is done by AWS. So this is fully managed. We do not have to take care of it manually. We do not have to write any algorithms or logic to do this. AWS takes care of the whole operation for you. All you have to do is define a good partition key. Now choosing a good partition key becomes really important because of how DynamoDB stores our items in table based on this partition key. So for a simple primary key, the good examples for choosing a partition key could be a user ID or a phone number, or you can choose the order ID as partition key, because these will be unique for each item and will also have a large number of distinct values relative to the number of items in the table. And because DynamoDB is optimized for uniform distribution of items across tables partitions, no matter how many partitions there may be, DynamoDB will make sure that all your items are equally distributed across all the partitions created for your table. Now these partitions can be spread across multiple different computers, so DynamoDB table doesn't run on a single computer in the backend, but instead it is distributed across an entire fleet of computers, or you can say SSD drives spread across different machines. And this is the reason why DynamoDB are infinitely horizontally scalable. So as your data grows, more partitions can be created on new SSD drives or computers. And this hash function will make sure that items with the same primary key get stored under the same partition, or at least close together. Now let's take a look on how you can create a composite primary key. So a composite primary key consists of a partition key and then a sort key. Now in this case, partition key, as in this example, our partition key is user ID and our sort key is order ID. Now in an orders table, we can have many items with the same user ID, as these users can have multiple different orders placed. So we can create composite ID in scenarios where you need to query, for example, your table by user ID, and you want to fetch all the order IDs, or you just need to fetch a single order for a user. So in this case, you can use composite ID, and you can fetch your data for user ID. Let's say you get 50 different items, and then you can filter those items using your sort key. Now again, same mechanism is used by DynamoDB to store and fetch data or your item from partitions. DynamoDB will still take your partition key, hash it using the hash function, and then try to store all the items with the same partition key under the same partition close together. However, these stored items for a partition key will be ordered by the sort key value. So to summarize, a new item comes in, DynamoDB checks for user ID, it hashes the user ID, which is the partition key, and stores it in partition. But it also checks for the order ID, which is a sort key, and makes sure while storing your item in partition, it stores in a particular order by order ID. So it makes it really fast for DynamoDB to do these operations.